Hello, all. Well, hopefully you got a decent try or decent practice at your attempt to incorporate an array into a program. Hopefully you have reviewed the solution to that assignment and also the accompanying video and have a pretty good idea now how to incorporate array, I should say, into your programs and the purpose of doing so. Once again, it's always nice to know why would you incorporate these tools. Again, as beginning programmers, I'm not teaching you things now that you need to force into your programs. It really just comes down to, can it help your programs? Again, we talked about the interesting problem and how we could approach that without an array. There's nothing wrong with doing that other than you would be writing a lot of code. And so, as professional programmers, our goal is to write code that, once again, is maintainable and readable. And so, if we're sitting there writing tons and tons and tons of code, for where an array can actually reduce that down to minimal amounts of code, that's something we would definitely want to do and something you want to be able to learn. Again, also what we're doing, as we continue on with learning about arrays and string manipulation and so on, is increasing your abilities and your knowledge and using the iterative structure. And I hope by now, based upon where we are in this course, you're starting to get more and more comfortable by incorporating the iterative structures of the different types of loops that are available for you, the do whiles, the do untils, and the for nexus. Again, we're going to spend the rest of this semester doing iterative structures. So by the time you get done, you'll be pretty good at the three structures of programming. I promise you, if you just keep at it. Okay, so where are we? So this week, what we want to do is continue our discussion on arrays and kind of add a little bit more to it. If you recall from last week, we sat back and we had our cookie counter, and that basically defined why an array would be very useful for us versus using a bunch of conditional code. For 10 classes, 100 classes, 1,000 classes, and so on, that code would exponentially increase. But with an array, it doesn't. And that's what I mean by it's kind of dynamic. It can handle just about any amounts that you give to it. All you got to do is change the array size and the code to add to it, like what we did here. Let's look at this here. Does not change. This code to accumulate the cookies does not change based upon the array being 10 elements long, or 100, or 1,000, or 10,000, or whatever number you want to put in there. Same thing to kind of process the array and get the largest, the classroom who has the largest amount of cookies sold. This does not change based upon the size of the array. And so when you read in my instructions that we know our program is now dynamic, it is. It can handle anything without really changing much to our program. That's all beautiful. But there was one thing that was interesting about this problem, and I wonder if anybody actually asked this question or thought about this question. It all worked really beautifully when our classrooms were numbered from 1 to 10, correct? I mean, so we could actually use the classroom number and subtract 1 from it to give the index. That's beautiful. With that said, how many classrooms or how many schools you know have classrooms numbered from 1 to 10? Let's think about Cincinnati State. Some of you may have been on campus, or some of you may not have been on campus. But if you're on campus and you go to the ATLC, where the majority of our technology courses are taught, we have 4 floors in the ATLC, and they're numbered based upon the floor you're on, from 101 to 102 to whatever number of classrooms on the first floor, all the way up to the 4th floor, where once again it's 401, 402, and so on. Well, okay, let's just say we wanted to do all those classrooms in the ATLC to do a cookie contest. Well, it doesn't work, does it? We don't have classrooms in a linear type order from 1 to whatever. We have classrooms named based upon the floor and then based upon, I don't know, some other type of random numbering scheme that they incorporated when numbering the classrooms. So it doesn't work at all. You may be able to look at the numbers and try to think of some logic to reduce it down to the actual index, but I'm not sure it's consistent or not on each floor. Let's take it one step further. Wondering if we don't even use numbers. Wondering if we name our classrooms based upon a name. Maybe it's classroom A, classroom B, classroom C. Things don't work anymore, and that's real life, correct? Having a classroom's a number from 1 to 10 probably is not real life. I'm not saying it doesn't happen, but probably not exactly perfect like we would hope to be. Well, then what do we do? All of a sudden, this becomes much more obnoxious, correct? This become obnoxious might not be the word, but it doesn't work. We just can't easily use our classroom as an index like we did here. So what do we do? Well, let's go back and look at our interesting problem and kind of talk about this a little bit, and then we'll introduce our next concept that can handle this. And so, kind of repeating what I just said here, if we look at our interesting problem and we know and we want to modify it, and what I did is everything that's in yellow or highlighted, I should say, has been modified in the problems, and it's available to you under with this video. So we're going to go. We're going to change things from 10 classrooms to 7 classrooms. All right. And instead of issuing a classroom number here, that's what was there before, it's going to be a classroom name. And the names of the classrooms, we're doing this for kindergarten now, the names of the classrooms will be entered based upon the names of the 7 dwarfs from Snow White. And I'm sure all of you know those, correct? Come on, all of you have to know the 7 dwarfs from Snow White. And so it's assumed that you'll know their names. I'm not going to give them to you. Anyway, I always let's see if you know the 7 dwarfs from Snow White. That's part of the assignments for this week. I'm teasing. Anyway, so we have 7 dwarfs. So we're naming these things afterwards. So how would we do this? How can this possibly be accomplished? So now what we're going to do is we would modify our program. And let's see, let me get back to my program. We would modify our program that instead of accepting the classroom here, we would basically have them either type in the name of the classroom, but probably better yet, we'll make it a combo box with the 7 dwarfs actually in there. All right. Okay, so I go get my 7 dwarfs. Then what? Then what? How does this work? Because what I still want to know is what classroom's winning, meaning I want to know if the classroom was sneezy, how many cookies they sold, or bashful, or doc, or grumpy, or dopey. Who else am I missing here? Happy. I don't know if I got all 7 or not. We'll talk about that. We'll do that a little bit later. All right. So that's what we want to accomplish, and that's what this video is about, to kind of like introduce this concept. More times than not, we don't have a perfect scenario where we can actually take an input and utilize it some way, somehow as an index. Most times we got to sit back and try to work with it but still use the power of the arrays to do so. Okay, and what we're going to do is introduce this concept called parallel arrays, and we'll do that in the following video.